Welcome. End of the year. Review of the finals. You made it. Hopefully you did. Alright, so actually if you're watching this, you most likely did make it. So, let's go finish this up. Today, we're going to start our final review with Chapter 2. We're going to go over what Chapter 2 was, and that was limits. Long ago, back in October, we ventured forward on our calculus journey. This is how we began. So, review today, first day of 5 in a review. We're going to solve limits graphically, numerically, analytically, solve special limits, understand one-sided limits, and understanding an element. So, hopefully, you already took the Kahoot, you did well in the Kahoot, and if you did not, this will help explain it if you did not catch what I went over in class. So, first thing, finding limits graphically. This is all a review. We've done all these notes before, that's why there's no animations for them. So, if you're going to find a limit of 3, the little minus sign means you're approaching from negative infinity. The plus superscript means you're approaching from positive infinity. In this case here, as you approach this point, the 3 from negative infinity, your answer is 4. Now what a limit is right before you get to that point, what's your answer about? Not necessarily at the point. As you approach 3 from positive, your answer is always your y value, 4. So it's 4 in both cases. Now look at number 2. I'm just going to stick with the limits from positive and negative. As you're approaching from negative infinity, approaches 2. As you approach from positive, 2 from positive infinity, approaches 2. Even though the actual answer here is not 2. So let's go back a little bit. So since both of these are 4, if your limit from the left and the right is the same, your answer is whatever that number is. So since you're approaching 4 from the left and from the right, your answer is 4. Now, if you have a closed circle at that point, f of 3 means what's the actual y value, pretty much y value, we'll just say that for now, when x equals 3. So when x equals 3, the value of y is 4. That's why they're all the same. So back to this one. We know that it approaches 2 from the left and the right. See, it's approaching 2 from both directions. So the actual limit there is 2 because it's the same number. Now, what is the actual value at 2? An open circle is a hole. That means there's no value there. So your actual value is undefined. Okay? So values can be undefined. Limits can't be undefined. This is like a quick re-lesson. Okay, so limit of 2 from the negative. Coming from the negative infinity. Your answer is 1. Approaching 2 now from positive, the answer is 4. They don't meet at the same point, do they? Since they don't, there actually is no limit there. The limit does not exist. Okay, so limits you may get do not exist. All right, now since they're both open circles, there are no closed circles here, your actual f of 2 is undefined. All right? These two from the left and the right have to meet in order for there to be a limit there. But there can be a one-sided limit. Problem 4. Slide over here. As you approach 3 from the negative, answer is 2. As you approach 3 from the positive, answer is 5. They don't meet at the same point, so there is no limit there. Limit doesn't exist. However, open circle, closed circle means f of 3 happens to equal 5. All right, that's a quick review on graphing. You can always go check back into the graphing videos if I have one up. And keep on going through that stuff. All right, that's like 2 point something. All right, so do the problems. Go. You get 10 seconds. Should be done. Or you can just pause it. So problem number 1. Limit of f of x as x approaches 1. So as it approaches from the negative side and the positive side, it approaches the same point, and that value is 2. Number 2. Limit of f of x as x approaches 4. Now this is x from the positive side. This is from the negative. Now as it approaches 4, so it's approaching 4. So what that means is 4 from the negative, the answer is 2. 4 from the positive, there's nothing. So what's the limit? It doesn't exist. You need to approach it from both sides, okay? Next one, number 3. As x approaches infinity, now this is also end limit behavior. Negative infinity is which way? This way. So as your graph is going this way, what's my actual graph doing? It's going up. And when you go up, which direction is up? Positive infinity. So it goes to positive infinity. Problem number 4. The limit of f of x is approaching 2 from the negative side. So it's approaching 2 from the negative side. So you go through your graph. You get to 2. That's 1. Up. Right before we get to 2. Our answer is, now one-sided limits always have to have a number. Answer is what? 1. All right, f of 0. What's my actual, do I have any closed circles at 0? The limit at 0, there's my closed circle. My answer is indeed 0. All right, so it's where the actual closed point is at. Now, if I was going to say what's the limit at 0, both of these approach here, the answer would be 1. All right, limit of f of x as x approaches 2. So as x approaches 2, from the left side it's 1. From the right side it's negative 1. Does 1 equal negative 1? Not in this world. So since they're not equal, the limit does not exist. All right, some other answers here in case you're wondering. The limit at 2, the limit at 1, you said was 2, right? There is no limit here. Limit at 0 would be 1. The limit at negative 1 would be here. That's like negative, like a quarter. All right, so you don't actually need a closed circle there. If the graph is just solid, that represents a closed circle. Limit at 3 would be 1. Okay, got it? F of 3 would be 1. Only open circles or asymptotes like destroy your f-ups. All right. Now let's move to the next one, the properties of limits, basic limits. So the limit of a constant is always a constant. So for instance, the limit of 3 as x approaches anything is 3. The limit of a billion as x approaches anything is a billion. All right, limit of x as x approaches c. So the first step when you're finding limits is always just plug in your c. So the limit of x as x approaches 4 is 4. It becomes algebra. You just plug in all your x's, whatever x approaches, in for the x's, and if you get a good answer, you're done. Easy peasy. Now, x to a constant is just whatever that constant is. You plug in there. So same concept here. You plug your 2 in for x. 2 to the third power. 2 times 2 times 2 is 8. So easy. Squeeze theorem. These are special theorems. Now, if x is 0, normally this would be undefined, doesn't exist, but the limit of sine x over x is always going to be 1. The limit of 1 minus cosine x over x, instead of being undefined, because 0 is in the denominator, is always going to be 0. Okay, we proved these and went through these earlier on in the year. This is a quick final review, so I don't think we need to do that. All right, some more rules here. Scalar multiplication. If you have a constant in front of the limit, just multiply by the constant. So for instance, x squared, remember you said plug the 2 in. Well, if you have a 3 in front, multiply the 3 when you plug the 2 in. 2 squared is 4. 3 times 4 is 12. I pulled this right out of one of our lessons. Some are different. So what you could do is when you have more than one limit you're dealing with, you would just add them or subtract them based on what sign it is. So 3x squared minus x squared, you're going to plug the 4 in for both of them. And you solve it like an algebra equation. 4 squared, 12 minus 16, negative 4. Wow, it's easy. Product. You can multiply 2 limits to each other. So, say you have a 5x and a 6x, 2 different functions. You would plug your 3 in for both x's. You would get 5 times 3, 6 times 3, 15 times 18 is 270. You can also do the algebra first. 5x times 6x is 30x squared. Then plug your 3 in. 30 times 9, 270. Which way's better? The way that you get the right answer. Quotient rule. Oh, make sure I'm not in here. You can divide them as well. So you can put your 1 in here. 1. 6 times 1 over 1 plus 3. 6 divided by 4 is 3/2. All right, and finally the power. You can raise a function to a power. So say it was 2x, the whole function to the third power. X is approaching 5. Plug the 5 in for x. 5 times 2 is 10. 10 to the third power is 1,000. Or you can actually do 2x to the third power. 2 to the third power is 8. X to the third power is 3. 8 times 5 to the third. 8 times 125 is 1,000. Got it? Another theorem. Whew, it's hard to teach months worth of stuff in like 5 minutes. All right, so theorem 2.7, back in chapter 2. Functions that agree at all but one point. So c could be a real number, f of x and g of x for all x is not equal to c in an open interval containing c. They talk fast. If the interval of g of x as x approaches c exists, blah, 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 blah. What it means is the two limits can equal each other. So all this fancy stuff says is you can reduce your problem and then find the limit that way. You don't have to use the exact method, or you don't have to use the exact writing it is. You can cancel stuff out in order to make things easier for you. So there are 4 simple rules. Rule number 1, plug in c and solve. This is how you should solve every limit. So if I plug in 1 here, 1 to the third minus 1 over 1 minus 1, I get 0 over 0 undefined. Now in the past, we say, oh, D&E, can't solve it. But you have to go to the next steps. Okay, so 0, I can't just do it the easy way. If I got a number here, you're done. Good job with your limits. Now, second step is to factor. All right, I can't factor this because this is the lowest form. I could factor a cubic because 1 and 1, in case you forgot, x to the third minus a to the third is x minus a, x squared minus ax plus a. Obviously, x is x, a is 1 here, right? So this would become x minus 1, x squared plus 1 times x, which is x, plus 1, over x minus 1. Now, after you factor it, this is why this rule is nice. You simplify or reduce. So I see an x minus 1 on top, x minus 1 on bottom. I cancel both those guys out. Now, by canceling this out, I no longer have 1 minus 1 on the bottom, which makes my answer undefined. So it gives me a good solid answer. So I just keep this, because this is a 1 and a 1, and this divided by 1 just as itself, x squared plus x plus 1. And now you're going to plug in c again and solve. So now, okay, I'm going to take my 1, I'm going to plug it back in. 1 squared plus 1 plus 1, 1, 1, 1, 1, 1, 1 is 3. Got it? All right. Let's go through some answers. And you couldn't do any of this at the beginning of the year. Now you guys should be experts. Limit of a constant. No matter what x approaches is that constant. So your answer should be 9. Very good. All right. Limit of 2x minus 5. Remember step 1. Plug in x. So if I plug 4 in here, 2 times 4 plus 5 is 8 minus 5. Minus 5 is 3. Yes, it is that easy. 9. Uh-oh. Plug in 3. 33 plus 11. Sorry. 3 squared is 9 plus 11. Over 6 plus 6. 20 over 12 is 5/3. Wait, that's it. 10. Up. Plug in 0. Answer's no good. If I plug in 0 here, I get 6 times 0 over 0, which is undefined. Is there anything here I can cancel out? I gave you the hint already. The purples. X to the 7's cancel out. Negative 6, 1 over 1. So what's the limit of negative 6 as x approaches 0? Negative 6. That's it. All right. Any questions with that? All right, 11. Guess what? Plug 5 in here. 25 minus 25 is 0. This becomes 25 minus 45 plus 20 is 0 over 0. So you're going to have to do something here. Factor the top, factor the bottom. X plus 5, x minus 5. Factors of 20 that add up to negative 9 are negative 5 times negative 4. What cancels out here? The negative x minus 5's. All right. X plus 5 over x minus 4. Now you can plug in your stuff. 5 plus 5 over 5 minus 4 is 10 over 1, which is 10. All right, number 12. Oh, remember any of these? Radical of x plus 5 plus 1 over x plus 4. How do we reduce these? Let's see who remembers. You multiply by the conjugate. Remember what a conjugate is? Radical x plus 5 minus 1. So you just multiply this by 1. Now by doing this, what's going to happen is you are going to fix the bottom. Watch what happens. The top becomes, when you multiply a radical by itself, it just becomes whatever's under the radical minus the radical plus the radical minus 1. Now, the reason we multiply by a conjugate is watch what happens. Anytime you do this, the middle pieces cancel out, leaving you with x plus 5 minus 1. And you're still left with the radical on bottom, but I think that might be able to help us. So let's see. So you're left with an x, 5 minus 1 is 4 on top. And on the bottom, you're left with radical x plus 5 minus 1. Now, do you see anything that cancels out here? Yes, x plus 4s. Uh-oh. The top becomes 1, not a 0. Anytime you cancel these numbers out, technically they become 1. So the answer would be 1 over radical x plus 5 minus 1. What number are we plugging in here? We're plugging in a negative 4. 1 over negative 4 plus 5 minus 1. Negative 4 plus 5 is 1. What is 1 minus 1? And your answer becomes 1 over 0. Uh-oh. So what's your final answer? Undefined. Oh. So the answer is technically DNE anyway. Oh well, we tried. At least you went through the motions, you figured it out, and you figured it was DNE. Now sometimes you will get answers though. Like if this was a minus instead of a plus, you would have got an answer. Alright? Alright, next one. Ready? These are the rules to live by. Step 1. You plug in C. Now, you either get an answer, you're done. If you get undefined, right? Factor, reduce and multiply by the conjugate, one of those things, plug in C. If you get an answer, you're done. If you get undefined, pretty much have to go back to making the table where you take all the values that are 1,000th, 100th, and 1/10 greater than C, 1,000th, 100th, and 1/10 less than C, and see if it's approaching negative or positive infinity. All right? If it is a one-sided limit, just use whatever C is. Drop the negative or positive and see if it actually gives you an answer. Okay? If it doesn't, once again, you're going to have to go back to making the table. The limit for a one-sided limit is never DNE, and the limit is never going to be undefined. If you get undefined, eventually in the end, it could be DNE, or the one-sided could be infinity, negative infinity. Got it? And this is more like one-sided limits. All right, regular limits, you would go to pretty much this step, and then it's DNE. One-sided, you need to go to the table. As far as limits approaching infinity, anytime a limit approaches infinity, your answer is going to be positive or negative infinity. All right, so if x approaches infinity, no matter what you raise it to, as long as it's 1, 2, or higher, right, your answer is infinity. If you're going to negative infinity, your answer is going to be negative infinity if your n is odd. Negative infinity to an even power is always going to be even, because any number, odd or even, to an even power is positive. When you deal with polynomials, as your n limit behavior here, as you're approaching positive and negative infinity, what you do is you pick the degree with the highest term. So for instance, x to the maybe 10th, if you have x to the 5, 4, 9, 6, okay, so whatever variable degree is highest, you pick that and then you just deal with whatever's in front, the sign, okay, and then you raise it to that power. And then you get your positive and negative infinity, because you go back to these two rules. When rational numbers work with positive negative infinity only, you can use your L'Hopital's rule. You take the highest degree term in the numerator. In this case, it was 3x to the 5th. You take the highest degree term in the denominator. In this case, it was x to the 3rd. Then you reduce it. You're left with x squared on top because you have 2 more x's on top. And then you solve. Negative infinity squared is positive infinity. Positive infinity or negative infinity divided by any single number in the world that's not infinity is just positive or negative infinity. All right? You may be fooled with the signs. Anytime you have infinity on the bottom, okay, so positive and negative infinity over any number is positive or negative infinity. Any number over positive or negative infinity is always 0. All right? And then radicals, the square root of infinity is infinity. The square root of a negative infinity doesn't exist, because you can't take the radical of a negative number. Got it? All right, let's do a couple n-limit behaviors and a couple one-sided limits. 3 from the negative, your first step should be to plug in 3, right? So if I plugged in 3, just forget that it's coming from the negative side, you get 23 over 0. Thought it was going to be that easy, didn't you? All right, so it's not that easy. So what we have to do now is we're going to have to take numbers leading up to -3. So say -3 is right here. We need all the numbers slightly. We're coming from the negative side. Oops, sorry, we're coming from the negative side. Say this is this is +3 right here. These are all the numbers before. So we have to do a little bit before, a little bit before that, and a little bit before that. So you make your table. So you have your 3 for your negative side. So we need a number a little bit less than 3. How about 2.999? 2 and 999 thousandths. Pick a number a little bit less than that. 299 hundredths. All right, you can do 2.9 if you want. But these are all approaching 3. So we know this answer is undefined, right? So you plug in both of these numbers into the original equation, you get some values. So when you plug this in here, you get -5,800. When you plug this into here, you get -58,964. So look at the jumps here. It's like an exponential jump. It jumps by 10. If I did another 9 on here and got even closer, this would be probably 589,640 something. I'm just guessing, but I'm pretty sure that's what it would be. Or there'd be some more 9s in there. All right, if I even got closer, it'd be like -5 million. So it'd get bigger, bigger, bigger. But it's getting bigger which way? Negative. So our answer here would be -infinity. All right? All right, let's try this one. This isn't a one limit. This is a n behavior. So when you plug in -infinity here, the L'Hopital's, you pick the highest degree term on top. 3, bigger than those. Highest degree term on bottom is 5. This is an easy one. So you drop everything else. You don't care about it. 8x to the third over 4x to the fifth. Reduce. That becomes a 2. Whoops, sorry. Those 3 all go away. 2 of them go away. You're left with 2, right? So you're left with 8 over 4x squared, 2 over x squared. Now, since x approaches -infinity, that is squared. -infinity squared is +infinity. Doesn't really matter, though, because any number divided by infinity, positive or negative, is always 0. All right? Last slide. See, this is an easy one. 15, 16. Oh, we got some special rules. So go back to one of the first slides we did and think back to the special, I forgot what it was called, special functions. So anytime you have 1 minus cosine x over x, it equals 0. Can I make this a 1 minus cosine x over x? Can I manipulate it at all? Of course you can. What can I take out of the top to get a 1 minus cosine x? A 6. So if I take a 6 out of the top, 6 times 1 minus cosine x over -5x. Well, I just want the x, so I don't care about the -5, right? So I'm going to pull that out too. So I pull out the 6 and the -5, which you can do, because I can always multiply it back in. And this piece right here now becomes 0. 0 times anything is 0. And the last one, pick the highest degree term. -4x to the 10th. -4 times infinity to the 10th. Infinity to the 10th is indeed infinity. Negative number times infinity is -infinity. And those are a really quick review of all your limits. All right, see, that wasn't too terrible, was it? No? Awesome. All right, so hopefully you guys remember all this stuff. All right, if you're in college and you're looking back at these notes because you forgot some of it, hopefully it helps you. Remember who helped you out, right? So, till the next review, hope you guys get it. Good. Woo!